Hi guys, today's topic is periodic table. In periodic table, we are mainly learning about periodic table, what is it, then periodic trends of the periodic properties. Let's directly start with modern periodic law. Modern periodic law. Modern periodic law. So I hope you know this. The physical and chemical physical and chemical properties physical and chemical properties of an element are periodic functions are periodic functions of its atomic number of its atomic number. So here the atomic number is the tool. Mendeleev, what he did, he used atomic weight as a tool. But Henry Moseley, who gave us modern periodic table, discovered atomic number and he used this as a tool and it fits perfectly. Means all the elements are arranged in the increasing order of their atomic number. So, what is the cause of periodicity? Cause of periodicity. Now, what is periodicity? Certain properties of elements are repeating at regular intervals, or either they have a gradual increase or gradual decrease in the properties. So that is called as periodic properties. What is the cause of periodicity, right? So the cause of periodicity is recurrence of electronic, not same, similar electronic configuration when you can have similar electronic configuration when the elements have same number of valence electrons, means there will be same number of valence electrons. So that will be reason for the periodicity of the properties of elements. Okay, so then after this we have the modern periodic table. So if you will be having that in your notebook, so please open it and see the information what I'm giving you now. So I'll just write a schematic diagram of that. So you will have the modern periodic table like this. So you'll be having vertical columns like this and horizontal rows like this, and you will have some two series like this. So this is a schematic diagram of modern periodic table. Okay, except this part. Okay, fine. Now what do you call vertical columns in the periodic table? You call them as groups. What do you call horizontal rows in the periodic table? You call them as periods. There are total 18 groups and 7 periods. 18 groups, 7 periods. Okay. In this you have specifically group 1 elements are called as alkali metals. Group 2 elements are called as alkaline earth metals. Group 17 called as halogens. Group 18 called as noble gases or inert gases. Apart from this, we have certain more categories in the periodic table. If you take group numbers 1, 2 and from 13 to 17, these all groups, these elements are called as representative elements. Okay, so group 3 to 12, these are called as transition elements. So if you see, this part will be your transition elements. This group 1 to 7 13 to 17 will be your representative elements. But you have two separate things here, right? So these are called, these will be group 3. These will belong to group 3, but period 6 and 7. So these elements which come under period 6 and 7 and belong to group 3, same group, you call them as inner transition elements. They have another name also, lanthanides and actinide series. Okay, so this is a quick introduction of the modern periodic table. Now let's go to the periodic trends, the trends of the periodic properties. The properties which repeat at regular intervals, they are called as periodic properties. We have some 6 periodic properties to learn and how they change across the period and down the group. For that purpose, I will take the second period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Noble gases will not take in this. So, and first group I will take sodium, Lena K, ruby, close friend. Okay, so this is second period, first group. Now we'll see different properties, how they change across this. Okay, first point, I'm going to take here atomic size, which is also known as atomic radius. What is an atomic size? This is the nucleus of an atom. These are the shells. The distance between the nucleus and the valence shell is known as atomic radius or atomic size. Understand? So how it is changing across the period and down the group, we have to understand that part. So here, for that, you need to know 2 points. It depends upon the 2 points. One, number of shells and nuclear pull, or it is also called as nuclear charge. Nuclear charge is nothing but the number of protons present in the nucleus. More the number of protons, more stronger will be the nuclear pull. Number of shells depends upon the electrons, how many are there. So as you go across a period, this is across a period, across a period, this will be your trend down a group, down a group. Okay, across the period when you go, the size will decrease, the size of the atom will decrease. As you move down the group, the size of the atom will increase, the size of the atom will increase. What is the reason? Very simple. As you move down the group, number of shells increase down the group because more number of shells are included, so the number of shells increase. It's just like initially the atom is like this, 1 shell, 2 shells, 3 shells, 4 shells, like that. So obviously the size will increase. And across the period, why the size is decreasing? Across the period, the shell number will remain same, but what is changing? Nuclear pull. So here across the period, what happens? The nuclear pull will increase because the number of protons increase, the number of shells remains same, so the electrons are pulled by the nucleus more tightly, hence the atom will shrink, it will become smaller in size. So therefore what you write here, now across the period it decreases, on the group increases. Okay, next point will take the ionization potential. First of all, what is ionization potential? Ionization potential is, say you have the sodium chloride, which is a solid, but in this we want only sodium, and you know sodium element is solid, but we don't want sodium in solid state, we want it in a gas state, so we'll convert into sodium atom in gaseous state. So it is an isolated atom, means it has no combination with any other thing, it is isolated. Now if you draw the orbit structure for this, for sodium 11 electrons, first shell, second shell, third shell. So 2 electrons here, 8 electrons you have to draw here, then 1 electron. How much energy you have to give to this sodium atom to take out this electron? To take out this electron, that will be your ionization potential for sodium atom. So now if you define ionization potential, it is the energy required to remove an electron from the valence shell of an isolated gaseous neutral atom. It is not charged, neutral atom. So that is called as ionization potential, ionization energy, ionization enthalpy. Now what is the trend of that? The ionization potential down the group, ionization potential down the group, it decreases. Down the group it decreases. Across the period it increases. What is the reason? Again you have to see here, across the period nuclear pull increases, it will hold the electrons more tightly, it will be difficult for the element to lose electron. Whereas if you come down the group, it's like there is a big classroom, the classroom is become bigger and bigger, the number of students are increasing, but the teacher is not so strict, then the teacher's hold to the last bench student will be less. The last bench student can go out of the class if there are 2 doors, right? So that happens here. But across the period what happens? The room is same, the teacher is becoming more and more strict as you go across the period, and it will be difficult for the students to go out of the boring lecture class, right? So that's why the trend will be down the group the ionization potential decreases. For these elements it will be less energy required to remove electron. Across the period it increases. Similar trend will be shown by electron affinity. Electron affinity. Okay, what is electron affinity? Let's take the same element, sorry, same compound. Okay, now just a little bit change. This time I will take this sodium chlorine. Chlorine is a gas already, but it is in molecular form. So you have to need chlorine atom in the gaseous form. Chlorine atom in the gaseous form. So chlorine molecular, atomic number is 17287. So 7 electrons in the outermost shell. So for chlorine it is very difficult to lose electron, but it is very easy to accept electron, right? So what happens here, when chlorine accepts electron, instead of absorbing energy, it releases energy. Here the energy will be released. Energy is released. Okay, so therefore electron affinity, how you define it? It is the energy released when an electron enters to the outermost shell of neutral isolated gaseous atom. Therefore electron affinity values will be in negative. Negative sign represents that energy is released. For ionization potential it will be positive. Okay, so all of these are energy, so the unit will be joules or kilojoules per mole. Okay, so what is the trend of electron affinity? Electron affinity trend, same like ionization potential. Electron affinity increases across the period, electron affinity decreases down the period. Why? Across the period the nuclear charge again increase across the period, so therefore the electrons will be pulled towards the nucleus and the external electron will be attracted by the atom. So therefore it is easy for the external electron to enter the atom, therefore large amount of energy is released. But here, because of the bigger size, the electrons will be difficult to enter the outermost shell as they are not tightly held by the nucleus. So the existing electrons will repel the incoming electrons. So therefore this is the trend for electron affinity. Next we have similar trend. I am taking the trends, the properties with a similar trend. Electronegativity. Electronegativity. Many people will have confusion between electron affinity and electronegativity. Remember, electron affinity is for single atom, but electronegativity always exists in polar covalent compounds. Say for example, you take HF. There is a covalent bond single, means two electrons are shared between hydrogen and fluorine. Since fluorine is more electronegative, what is electronegativity? It is a tendency of the atom to pull the electrons towards itself in a compound or in a molecule. So the two electrons will be towards fluorine like this. So there will be slight positive charge on the hydrogen, slight negative charge on the fluorine. So this is called as electronegativity. What is its trend? So trend of the electronegativity across the period, this is electron affinity here, right? So this is electronegativity increases across the period, electronegativity decreases down the period. Again, non-metallic character increases, the non-metals pull the electrons towards them, so electronegativity increases. Metals always try to lose electron, right? So they are more electropositive than electronegative, so they will be having less electronegativity. Again, reasons you have to tell based on the atomic size as well as nuclear charge, so that doesn't change. Next property after electronegativity is non-metallic character. Non-metallic character. Okay, you can see from the periodic table itself, as you move across the period, initially they are metals. So here boron is a metalloid, carbon, nitrogen, oxygen, fluorine, these are non-metals. So means across the period non-metallic character increases. Down the group non-metallic character decreases. So to give this example for down the group non-metallic character increases, take carbon group. Carbon, silicon, germanium, then you have tin and lead. So if you see, carbon is non-metal, silicon, germanium are metalloids, tin and lead, they are metals, metalloids. So you can see here non-metallic character is decreasing down the group. So exactly opposite character will be there for metallic character, metallic nature. Non-metallic means non-metals tend to accept electrons. Metallic nature means metals tend to lose electron. So opposite trend will be there. If you go across the period, metallic character decreases. Down the group, metallic character increases. So means lithium, sodium, potassium. So sodium is more metallic than lithium, potassium more metallic than sodium, rubidium more metallic than potassium, like that. Across the period, the metallic character decreases. They will become non-metals. So this is the trend of metallic character. So how many are there? 1, 2, 3, 4, 5, 6. So all are done. So the easiest way to remember these, IPN men. Okay. Electron affinity, non-metallic character, electronegativity. So these all show same trend. What? Across a period, across the period they will increase, they will increase. Down the group they will decrease, down the group they will decrease, right? So what are left? Atomic size, atomic size and metallic character, metallic character. So you can remember atomic size and metallic character or metallic nature also. ASMN, there was a film called Ionisation Narayana. So if you remember that, so across the period, what happens to atomic size? It decreases. Down the group, it increases. Down the group, it increases. Okay, so these are the simple techniques to remember. Last one point I just want to give you. There is one exception here. Many people do mistake in that. exception regarding electron affinity values. If you take particularly halogen group F, Cl, Br, I, not astatine. So here electron affinity down the group, what happens? Decreases. So you expect that if they ask you to write for these, write decreasing order of electron affinity, you may write F less than Cl less than Br less than I. Decreasing order, fluorine more electronegative, like this. Okay, but there is an exception for fluorine and chlorine. So the fluorine has lower electron affinity value than chlorine, so therefore the order will be chlorine greater than fluorine, greater than bromine, greater than iodine. So this will be correct trend for electron affinity values for halogens. This will be the wrong trend. So this is what you have to remember, the exception. And for noble gases, as I said, electron affinity will be negative value, but for noble gases it will be in positive. Means here energy is not released. Actually you have to give energy to give electron into outermost shell of the noble gases. Okay, so this is the quick revision of periodic table. Hope you like it. Thank you so much for your time.